this is another one of those question sets. So I'm trying to put these question sets as the do now so that you get used to answering multiple questions based on a given set of information. So for this, these 4 questions, it's based on this scenario at the top. They give us a balanced equation, and they tell us some information. Essentially, we put a mixture of copper and aluminum in a beaker, react 15.8 molar nitric acid with that mixture, and they give us the reaction between copper and nitric acid. And then it says the student observed a brown gas was formed and the solutions turned blue. And then we have these 4 questions. So the first thing that I always recommend doing is if you're given a balanced equation, star the equation or like underline, box the whole thing. That way it's easy for you to go back and reference the equation if needed in case you have to do stoichiometry or anything like that. So number 1 says, which of the following is true about the reaction? And if you read the 4 choices, we notice that it's either a Bronsted-Lowry acid-base reaction or a redox reaction. So the first thing that you want to do is think about what each type of reaction would look like. So Bronsted-Lowry acid-base reaction is when you have a proton donor and a proton acceptor. So in order for it to be a Bronsted-Lowry acid-base reaction, we should see an H+ being donated from the acid and accepted by the base. If we take a look at our reactants, we do have an acid here, HNO3. So we have this H. If this were a Bronsted-Lowry reaction, this H would be donated to the copper, and on our products, we would see copper with a hydrogen and NO3-. But if you look at the products, we don't see anything like that at all. So this is not a Bronsted-Lowry acid-base reaction. We can eliminate A and B. It's going to be important that you use process of elimination as you're going through multiple choice questions, which means it has to be a redox reaction. If it's redox, assign oxidation numbers. So go through and assign oxidation numbers. Remember, any element has an oxidation number of 0. Oxygen is always going to be -2. So each oxygen will be -2 unless it's part of a peroxide. So H2O2 is hydrogen peroxide. In that case, each O is -1. Hydrogen is always +1 if it's with nonmetals. And so based on that, you can figure out what nitrogen would be. Remember, the total oxidation states have to equal 0. So H is +1, there's 1 of them. Each O is -2, but there are 3 of them. So then you need to think about what would nitrogen have to be to make this entire thing equal to 0. It have to be +5. So that means there's just 1 nitrogen, so it's +5. So here are the oxidation numbers for the reactants. Then assign oxidation numbers for the products. Copper, you can actually do like the reverse crisscross method to figure out copper's oxidation number. It's the same as the charge if it's in a compound. So copper is actually +2. Well, now I can see right away that copper went from 0 to +2. If copper went from 0 to +2, copper was oxidized. But if I look at C and D, both of them say Cu is oxidized. So then we have to continue assigning oxidation numbers. NO3 is going to actually be the same as over here because NO3 always has to equal -1. The charge of NO3 is -1. N is +5, each O is -2. Now I'm going to just keep assigning. Each oxygen is -2, which means N has to be +4. So N is +4, O is -2, and then over here, each H is +1 and O is -2. And so now you can look at C and D. So C says that H+ is reduced, but H is +1 on both sides. So H isn't reduced, which which means D must be our answer. And it says the nitrogen atom in NO3 minus is reduced. Nitrogen goes from +5 to +4. Now this nitrogen stays +5, that's fine. But the other nitrogen is reduced from +5 to +4. I had a question in the other class. Well, what if nitrogen went to +6 and down to +4? Can you have one atom being oxidized and reduced at the same time? The answer is yes. You can have an oxidation and reduction of the same atom as long as you have an oxidation reaction and a reduction reaction occurring. Doesn't matter if it's the same atom or different atoms. But for number 1, this was looking at identifying the type of reaction. So that was unit 4. Unit 4 is looking at types of reactions. Number 2 says the students determined that the reaction produced 0.01 moles of copper 2 nitrate. I'm going to underline that given information. Based on the measurement, what was the percent of copper by mass in the original 2-gram sample? Well, I'm going to do the math up here. Remember, percent by mass is part over whole. So if you're looking for the percent by mass of copper, we are looking for the mass of copper over the total mass. And we multiply by 100 because it's a percent. And so if we look at what we're given, they give us moles of copper 2 nitrate and then grams of the total sample. So they give us 2 grams. They tell us that the total mass is 2 grams. So we need to figure out, based on the number of moles of copper 2 nitrate produced, what mass of copper is that? And so start with your information that you're given. 0.01 moles of CuNO3-2. Our goal is to take that information and get to grams of copper. So if I have 1 copper 2 nitrate, how many coppers are there in there? Just 1. That should be 1 Cu. And then you go 2 grams. Now this requires us to do math without a calculator. Molar mass of copper is 63.55. So if you take a look at this math, it's 0.01 times 1 times 63.55 divided by 1. 0.01 times 63.55. Remember, we don't get a calculator. This is a trick that I do with multiplying with decimals. Turn this 0.01 into 1. Think about how you have to move the decimal. I move it 2 times. I move it twice to the right. What is 1 times 63.55? 63.55. But now move the decimal back to where it should have been. I moved it twice to the right, now move it twice to the left. So 0.01 times 63.55 is 0.6355 grams. There's our number that goes on the top. Now, you would not be required to do this without a calculator. This is where estimating comes in. If this were 50%, if the sample were 50% copper, what number should be on the top? What's 50% of 2? 1. If this were 50%, it would be 1 over 2. 0.6355 is less than 1, so it's going to be a little less than 50%. So you can eliminate C and D. Now we said 0.6355 is a little bit less than 50%. But what answer choice is a little bit less than 50%? B. And if you want to take it even a step further, 25% of 2 is 0.5. Well, 0.63 is greater than 0.5, but less than 1. So our answer should be somewhere between 25% and 50%. And our answer is. So that's looking at doing a math problem without a calculator. If you get to a question like that, you can always skip it and come back to it. Right? You're not expected to answer every single question on the multiple choice. The average on the multiple choice is usually a 30 out of 50. Right? So that's okay. If you get a 40 out of 50, that's a very good multiple choice score. So it's okay to skip over some or to guess on some. Number 3, in one student's experiment, the reaction proceeded at a much slower rate than the other students. Which of the following could explain the slower reaction rate? So slower reaction rate means we're looking at kinetics. So we want to look at which of these answer choices would cause the rate to be slower. Remember, with reaction rate, we are thinking about collisions between reactants. So when we looked at kinetics, we were focused on the reactants. The rate law was rate equals K times concentration of reactants. So you're thinking for these, what are these going to do to concentration or to the collisions between the reactants? If they increase the collisions, that increases the rate. If it decreases collisions, it decreases the rate. Our goal is to figure out which one produces a slower rate. So in answer choice A, it says that the student's sample metal was much smaller than the other student's samples. So if the pieces were smaller, that's like taking a block of salt and breaking it down into crystals. Well, if you have something as crystals, is that going to react faster or slower than a big block? Faster. So this is actually going to increase the rate. That increases the surface area. So that's not going to be our answer. For B, the student heated the reaction mixture. Well, if you heat something up, if you increase the temperature, what's that going to do to the rate? Speed it up. That's not going to be the right answer either. C says the student used a 1.5 molar solution of HNO3 instead of 15.8 molar solution of HNO3. So instead of using a high concentration of a reactant, they use a low concentration. Use a lower concentration of reactant, what's that going to do with the collisions between the reactants? It's going to decrease them. A lower concentration means less collisions between reactants. Then D says the student used a 3-gram sample instead of a 2-gram sample. Well, the entire mixture, that's not going to actually affect the rate. That's just going to affect the time that it takes for everything to react. It's not going to affect how fast the reaction occurs. It just means instead of the quick reaction occurring in 5 minutes, maybe it takes 7 minutes. So 3 is C, and then finally 4. So for number 4, this is looking at absorbance versus concentration. So this is looking at a Beer's Law type question. This was part of Unit 3, but we see it with kinetics as well. So to determine the moles of copper, student measures the absorbance. The data recorded by one student is shown in the table, which is an error that the student made. So take a look at the values and see if anything looks off. As absorbance or as concentration increases, absorbance should also increase. It's just kind of what Beer's Law says. As concentration increases, absorbance increases, especially because this is a blue color. Spectroscopy is used with colored solutions. So as the concentration increases, the color gets darker, it absorbs more light. Well, if you take a look at this, absorbance kind of increases here, but notice that these two numbers are switched. Because it should go 0.059, 0.117, 0.235, 0.468. So those numbers are switched. So we need to look at which of these answer choices matches the error that these two are switched. So if you read through the answer choices, A says that the sample wasn't diluted properly. Well, if it wasn't diluted properly, that's going to affect all of the absorbances. Spectrophotometer was calibrated with tap water instead of distilled water. That's actually not going to make a difference. Tap water and distilled water are both colorless. That's not going to affect anything. C says the student labeled the cuvettes incorrectly, reversing the labels on 2 of the solutions. Well, if a student switched the labels, would that fit this mistake of the table? Yeah. So C is actually our answer for 4. An inappropriate wavelength, that would change all of the absorbance values, not just 2 of them. So for this, 1 is D, 2 is B, 3 is C, 4 is C. So this tied in reactions, stoic, kinetics, and Beer's law, which is actually from Unit 3. So for tomorrow, there's just some recommended stuff in Crash Course. These are actually the last 3 chapters with new content. This covers delta G, delta S. And then we won't get done with all the multiple choice questions during class. And so what I told first period to do is just check answers, just look through them. I'm giving you extra multiple choice, so we're not going to get to all of them today at all. But you can actually look through them, see what questions you have, and then just have more multiple choice questions to work through and to practice doing without a calculator. Before we get into multiple choice, just some quick things about the AP test in terms of what you should bring. So one question was on if you could bring mechanical pencils. The answer, as far as College Board says, is no. You need number 2 pencils like the SAT. I'm going to double check and make sure that if you don't have number 2 pencils, if they'll have some for you. If not, I'm pretty sure I have a box of them. I can give you number 2 pencils to use as well. For the free response, you can use blue or black ink, or you can use a pencil. The only things you can use on the AP test are number 2 pencils, are pens with blue or black ink, and then a calculator. So tomorrow we're going to start reviewing free response questions. Use whatever calculator you're planning on using for the test as we go through free response. You can use one of mine. Like if you don't have a calculator or you can't find your calculator, you can use one of mine on the AP test. But just make sure then that you're using one of mine during free response, because you don't want to get to the free response and be like, I can't find the exponent button. So just make sure that you're using your calculator. You can use a graphing calculator. It doesn't have to be one that looks like this. You can use graphing. As long as it's not like a computer, you're fine. And then other things, so just don't bring, just like the SAT, if you have your phone, they'll probably have you turn it off and set it somewhere. If you'd rather leave it in here, Friday is an in-service day, so I'll be in here probably all day. So if you want to bring it in and leave it in here, instead of leaving it in whatever box they have you put it in, you can always leave stuff in here. So you can come in here, drop stuff off, and then you can go down. If you have Apple Watches or anything like that, you can't wear those. Anything that makes noise. So even if you have a watch, just make sure it doesn't make any noise. If you're in the LGI, there's a clock behind you in the LGI. The LLA, I don't think, has a clock. And I don't know if you're going to be in other classrooms or anything, but there aren't clocks unless teachers put them in there. So if you have some sort of watch that doesn't make noise, you can wear a watch just so you can reference time. And then I always just recommend for the free response, if you're going to use pencil, just have a good eraser. Whether it's one of those like pink erasers or something like that, just so if you need to erase a lot of stuff, sometimes the number 2 pencils, those erasers kind of suck. So just have a nice eraser to use. Make sure your writing is legible. They're actually scanning the free response questions to send to the teachers to grade. So make sure that it's easy to read. When it gets scanned, it's going to be easy for those that are grading it to read. So just some things for the test. Remember, it's next Friday. be here by 7:30. And then once I know the rooms that you're testing in, I'll tell you what room you'll be in. So they're probably going to split you guys over 4 or 5 rooms, I would guess, because there's 60 of you taking the test. So before we get into multiple choice, if you didn't pick up the multiple choice questions, they're in the top tray, so you can grab those. Just some strategies for multiple choice as we go through and practice today. One strategy that I think helped the other class is go through the test 3 times. The first time you go through the test, if you look at a question, you know how to do it, and it's quick to do it the first time through. So you look at a question, you look at number 1, you're like, oh, it's ionization energy, wants to know how many valence electrons there are. Do it quickly, right? So answer the question and then move on to number 2. If you look at a question, so you see number 2 and you're like, okay, I see this is an empirical formula question. I know how to do it, but it's going to take me a little bit of time. Then put a check mark next to it. All right, so then you know that the next time you go through, you can answer that question. And then you get to number 3 and you're like, oh, this says something about equivalence point. I have no idea. So put an X next to it. The ones that you put an X next to, you go back through the 3rd time. If you still aren't sure how to do it, guess. So when you go through 3 times, the first time you go through, you do all the questions you know how to do and the ones that don't take you much time. Then you go back through the 2nd time and you do all of the ones that you put a check mark next to. Ones that take a little bit more time, just keep an eye on how much time you have. And then the 3rd time through, do the ones that you have no idea how to do. Try to eliminate answers if you can. And if you still aren't sure, take a guess. Because you'd rather have a 25% chance, or if you can eliminate 2 answers, you have a 50% chance of guessing it right than leaving it blank. You're going to miss it whether you leave it blank or whether you guess and it's wrong. So you might as well make a guess. Your answer choices are only A through D, so don't fill in E. Right? You won't have any E answer choices. But just using that 3-time pass helps. So some tips that other teachers or that I've seen that helps with multiple choice. When you go through a multiple choice question, circle your given information or underline your given information, star your balanced equations. If you have to do math, estimate your numbers. So 3.8, round up to 4. Round your numbers. If you have any obvious wrong answers, eliminate those. Strong bases should have a pH above 7. Cross out anything below 7. This is a big one. If you have decimal values, use scientific notation. Put decimals into scientific notation to make the math a little bit easier to use. I handed out this AP mental math sheet a while ago. And I put the short link up here. But this shows how to do scientific notation. So you're multiplying, you're dividing, you're adding. Shows you how to use scientific notation. But that helps to avoid any kind of decimal point errors. If you're multiplying scientific notation, you add the exponents. You're dividing, you subtract. If you're taking scientific notation to a power, you multiply those exponents. If you need to take the root of a scientific notation value, so let's say you're taking the square root. Well, that means that your exponent should be divisible by 2. You're taking the cubed root, your exponent should be divisible by 3. And then going along, just underline your keywords. So you can write all over the multiple choice test. So do that. Star, underline, circle. Read things carefully. Multiple choice is not all math. We're focusing on the math stuff today, but multiple choice is not all math. Usually there's maybe a fourth of it that's math, if even that. If you're using ratios and it just says equal masses, you can pick the masses. You can pick the values. Start with 100 grams of each. All right, you can pick how much you start with. And then when we look at KSP, one teacher recommended memorizing the KSP for each ion. So what that means is if you have 2 ions in your solid, then KSP is S squared. You have 3 ions in your solid, KSP is 4S cubed. So just memorizing what your solubility and KSP equations would be. You can always write your KSP. It's just going to save you a little bit of time. So what I want to do is actually look at number 1 of the multiple choice together, and then I'm going to actually have you guys working in either pairs or small groups. And you can work on your own if you want. Like if you want to work on your own and try them, that's fine. But we're going to go through number 1. So again, if you don't have the multiple choice, it's in the top tray. But multiple choice question number 1 says the pH of water changes with temperature. What is the pH of pure water at 59 degrees Celsius if Kw is 9 times 10 to the negative 14? So pure water, remember, is the definition of a neutral solution. Pure water is neutral. Neutral is not a pH of 7. Pure water is neutral. And neutral is when H plus equals OH minus. So I'm just going to write that down underneath pure water just so that I remember that that's neutral. That's what neutral means. If I'm finding the pH, that means I need the negative log of the H plus concentration. And so for this, what we need to do is we need to figure out first what is the H plus concentration at this temperature so that we can plug it into the pH. So we have to use this idea of Kw. Now remember on your equation sheet, you have this on your equation sheet. And your equation sheet says equals 1 times 10 to the negative 14 at 25 degrees Celsius. Well, we're not at 25 degrees Celsius. We're at 59 degrees Celsius. Equilibrium constants change with temperature. And so Kw changes with temperature. So we can use this H plus times OH minus equals Kw. Our goal is to solve for H plus. If I write this down, H plus times OH minus equals 9 times 10 to the negative 14. I know I want to solve for H plus, but now I still have OH minus. This is why we wrote this down. If I want to solve for H plus, and I just label H plus with the variable X, what is OH minus? It's also X, because in pure water, in a neutral solution, H plus equals OH minus. Well, X times X is X squared. Now here's where we're going to practice without a calculator. How do I solve for X? Take the square root. Well, if I want to take the square root of this, I'm going to write it this way to make the math a little bit easier. Taking the square root of something is taking something to the 1/2 power. When you take the square root of a scientific notation value, take the square root of the number in front of the multiplication symbol. What is the square root of 9? 3. Then we have times 10 to the negative 14. This is why I write it like this. When you have an exponent to a power, multiply those two numbers. What is negative 14 times 1/2? Negative 7. There's our value of X. And remember, X represents both H plus and OH minus. There's our H plus. So now if I plug this into the pH, negative log of 3 times 10 to the negative 7. Now remember, if this were a 1, so if this were 1, is the number 1 times 10 to the negative 7. Remember, we can just use the exponent. So if this were 1, pH would equal 7. But it's not a 1, it's a 3. Which means you need to estimate. So since this is a 3, subtract 1 from the pH. And so what you actually would get is 6 point something. You subtract 1 from the pH. If the number in front of your multiplication, when you take the negative log, is not 1, you still can use the exponent, so 7, but subtract 1 from it. So your pH would be 6 point something. Well, which answer choice matches that? B. So this is reviewing scientific notation, right? The idea of neutral solutions, scientific notation, and then the idea of estimating pHs if that number in front is not a 1. So what I want to have you guys do is actually try some of the questions, then we'll go over the answers, then you'll try some more of the questions.